Hi, this is Roman, and today we're going to continue on the theme of probability, and we're going to scratch the surface of the idea of standard deviation, and really discuss how we might want to do this using the 3 reads activity with an engaging activity for students. So I'm going to just review a few facts on standard deviation here. That you might want to tell the students before you start explaining this, especially if it's the end of geometry and it might be their first exposure to a topic like standard deviation. So a very basic definition would be that standard deviation tells us how to spread out data, or how spread out data is, and it is a measure of how far each observed value is from the mean, or possibly use the word average for students as well there. One more thing that you could mention, and that's going to be within reference to the 68, 95, 99.7 rule, and it's not necessarily vital to this activity, but it is something that carries heavy weight within that topic, and it might be something interesting to talk about. So what is normal? When data follows a normal distribution, we can determine what percentage of observations fall in a given distance away from the center. More specifically, we know the following: approximately 68% are going to fall within 1 standard deviation from the average, 95% will fall within 2 standard deviations from the average, and then 99.7% of observations will fall within 3 standard deviations of the average. And then we want to just highlight to students that here what we're doing from the average is adding and subtracting 1 standard deviation for 68% of the data, or adding and subtracting 2 standard deviations for 95% of the data, and adding or subtracting 3 standard deviations for 99.7% of the data. And here I have the formula to find a standard deviation. And again, you might want to just show this before you begin the activity as front-loading data that they're not really going to investigate with this first activity, but they should have a grasp of the adding or subtracting idea to fall within a standard deviation. So I'm going over a 3 reads activity for this specific activity. I found this very engaging with students. We're going to the 2014-2015 season of basketball, and we're saying that it's argued that Steph Curry is the most consistent top shooter in the NBA, and we have the data from the top 25 scorers, and it'll be nice because it's not that far off in terms of right now being 2021 with some of the best players still here. So if I take a look at it, right, we have games played following the basketball player's name, points per game, and then the standard deviation. So it's going to be a very interesting question for students to engage in, especially if you have some basketball fans in your class, which I personally do, right? I will point out a few things. There is one typo here. I am almost convinced that Raphael Turtlebrook is Russell Westbrook. So you might want to correct that for your students. This was actually an activity from a textbook, so I'm pretty sure that was a typo because I do not know of a Raphael Turtlebrook, and I'm pretty sure he did not play in the 2014-2015 season. So here, students could really start thinking of the ideas of consistency and standard deviation, right? And then if we look here, right, Kawhi Leonard has the lowest standard deviation, but maybe that means he's the closest to getting this average of 21, give or take that standard deviation, right? But if we look down these numbers, all right, we might want to conclude to students that Kevin Durant might be our choice because at his average of 28, give or take 5.45 points, we're getting a lot every night compared to all the rest of our players, right? If you look at James Harden, who has a higher average, right, he could have possibly 9 points less on a night, which wouldn't be as impactful. And then if we go back to the question, we want to really take a look at Steph Curry's average of 30 and that standard deviation of 10. And what does that mean? And I think this is really interesting for students in terms of if they're watching these games day and night, right? Maybe they can start talking about, well, one night he has 60 and another night he has 10. If he's so good, why would he have 10 points a game, right? And then it sparks a lot of discourse. You might have some students who point out the fact that, in this season specifically, they blew out a lot of teams, and the good players stopped playing. They just sat on the bench because the game was out of hand. So again, since this is a new topic, I framed it in a 3 reads activity. So again, first experience to students. For the first read, I would suggest they annotate the following: words they don't know, and compose questions that they'd like to have clarified, right? Maybe they don't understand the standard deviation. Maybe they want to know why games played is important in the context, right? If we had a player with 3 or 4 games played, can't really make an assumption there based on the whole season. Our second read is to think about the main idea or analysis. So what is the question we are trying to answer, right? And we will have students who, just like me, veer off of Steph Curry and start looking at some of the other players here. How's the problem like something that we've seen before? We've definitely seen averages in a student's high school career up to geometry. Can they think of an approach? I think that's something very interesting. And what do they notice and wonder? I think that's a very rich, open-ended entry point for all students. And then the third read here, I actually want to make this on one page. So should you want to print this as I share this activity, it will be an easy worksheet to hand out. And I will update this to make it one page. The following questions in groups, right? What do you think about what your peer said? As we start sharing what we gathered from our second read, do you agree or disagree, and why is that true? And again, this is one of the ones that'll promote a lot of discourse, because you are going to have a lot of students who say, well, the one with the most points is obviously the most consistent because he's bringing the most to the game, right? And then you do have a few situations where the higher scorers have high standard deviations, and what does that really mean? I believe in this time it's be really interesting to look at Kawhi Leonard before he went to Toronto and won a championship, to show how these statistics play a huge role in deciding how valuable a player is. So again, this was in terms of just the introduction that we're doing into probability towards the end of our course, and a fun activity to introduce the very basics of standard deviation. I hope you guys found this activity useful.